SolidWorks Simulation, Lecture 15, Part 1, Motion Study, Simulation of a 4-bar linkage mechanism. This is a 4-bar linkage mechanism, and I'm going to fix the bottom linkage. Right-click the mouse, choose Fix. So I have fixed the bottom linkage. You can see that there's a F here, representing that the bottom linkage is fixed, and all the other three remains floating. So I can test the mechanism a little bit. So the bottom linkage is fixed. So now for the preparation step, I need to load the software. Here, add in. The software is SolidWorks Motion here. Now I have loaded the software Motion. Now I enter the interface of Motion here. This is the interface for modeling. This is the interface for motion study. So I'll give this linkage a motor. You can define motor or define a force or torque, even a spring force, a damper, or a contact, even gravity. So for now, I'll give it a motor on this linkage. Here you can toggle the direction of the rotation. I'll make it counterclockwise. And I'll define it as an oscillation. The amplitude will be 90 degrees. The average angle will be 0 degree, which is the position right now. So it'll oscillate back and forth 45 degrees. And the frequency will be 1 Hertz. So this is the loading that I'll give this mechanism. You can define the time span to be any time, but I will leave it as 5 seconds as default. So I'll solve for the study. Now the solution is finished, so I'll get the result. I'll define a displacement velocity or acceleration at this point, and I'll choose a linear acceleration. The amplitude or magnitude of the linear acceleration at this spot. So now I'll check this box. There's an arrow here signifying the linear acceleration of the mechanism at this point. And the direction of the arrow means the direction of the acceleration at this spot. And the length of this arrow represents the magnitude of acceleration at this point. So I can plot the research, and I can play the animation. This is the animation. So you can see that with the motion of mechanism, the linear acceleration of this spot is changing all the time. And you can see that at this spot, for example, at this point, the mechanism at this position, the linear acceleration of this point gets to the maximum value. And at this spot, at this position, the linear acceleration of this point is at its minimum value. So you can see that there's a constant changing of direction and magnitude of the acceleration at any spot on this mechanism. So this is the part 1. You can still plot out other values. For example, the angular velocity or angular acceleration, even the position of each spot on the mechanism.